Okay, so we'll see how far we get on this. I'm a big fan of scale models and discussion of things that are not quite as they might initially feel or that you might think they are. And part of the reason I like to think, I'm interested in this stuff is, well, that's frozen into the TV.
What is that?
I don't know, it's not from the screen.
We'll worry about
It's
it later.
fine.
It's fine. It's not my
it's
TV.
anyway, measurement is weird, and we're really bad at estimating things. I mean, when you think about it, we're all, advanced apes. We're not used to dealing with millions of people or things that are much bigger than banana, this kind of stuff. And, sizes of things, numbers, they're all very unintuitive. They're confusing. We hear all the time, everybody talks about how bad they are at math, how much they hated math in school. It's very, very common. And also, the names of things are unintuitive, and they make people come with preconceptions to what they think numbers are. So anyway,
I have a question.
Yes.
Did you wear your space shirt specifically because you're going to be talking about how big
yes,
you are?
I did.
I'm glad you coordinated your outfit as well.
I did in fact do that.
Hell yeah.
If we're going to talk about scale of things, we're going to need some help. So I did some poking around and I found this nice person here.
Oh wow, who's this guy?
Excuse me there, sir. Can you,
What was this taken?
Oh yeah, blast it. Someone left it at 69 last time. You can blast that.
That's fine. So excuse me there, but can you help us? Thanks, Brian.
Hey.
All right, so,
Nice hair costume.
okay, so Brian, I need you to help me with something. I need you to sort magic cards for me.
Sure.
And I can only pay you minimum wage, though.
Bummer.
So, sorry about that. Thank you. So, anyway, money. How long? I'd like some gut feelings from everybody. How long do you think it would take our good friend Brian here to make $1 million working minimum wage if he doesn't have to pay anything, like no taxes, no expenses at all?
100 years.
100 years.
1,000 years.
1,000 years. Anyone else?
I know the answer. I shouldn't say it.
Okay, sure.
17 months.
All right. So,
Does he have to sleep?
yes, this is just working regular full time.
Okay.
So 8 hours a
regular
day.
full time. Okay,
Yeah.
so isn't every hour available?
5,000 hours. 5,000.
You're close. Somewhere in there is pretty close because the answer is 56,000 hours.
Whoa.
And how long do people think 56,000 hours is in terms of other
A
time?
few years, because Brian gets weekends.
300 years.
It's like a decade or two.
Yeah, pretty close. You're a little bit over.
That's 12 years?
Not quite, but again, you're somewhere in there. It's 28 years.
Ah.
Damn.
But of course, this is really small change, so we're going to do something I think we're all very familiar with, which of course is that money gift from earlier. So how long do you guys think it will take Brian to make $1 billion doing the same job?
Second GIF on Google.
100 years.
100 years.
Can I go by the measure of hours?
Sure.
560 million hours.
Okay.
Just
Yeah, so
Yeah.
you guys are right.
Thousands
But
of years.
the thing that about a million and a billion that you find, and you see with the 100 years thing, is a million and a billion, the words are really, really similar. And there's some weird gut thing that people tend to think that a billion feels kind of like 2 million. So they kind of think it's like twice as much, which is where the insanity of billionaires comes in. Because of course, it's 28,000 years,
Jesus
or 56 million hours of work.
Hey.
So,
Because a billion is a million.
because a billion is 1,000 million.
1,000 million.
So he will be working since what is it, the beginning of ancient Egypt till now?
No, way more than that.
No, 28,000.
No, that's-
20,000. Ancient Egypt's like
actually-
5,000 years ago.
Yeah, sorry, actually.
Speaking of scale.
We'll get to that eventually,
Oh, boy.
possibly, but probably not today.
Oh, no.
Anyway, so well, now that we have all this money here,
Hell
and
yeah.
Brian has this cool $1 billion now that he spent 28,000 years sorting magic cards, might be enough time to do that. I'm not sure. There's only one thing left to do, which of course we're going to send Brian. We're now going to talk about our boy the astronaut. So I've got my good Douglas Adams quote here. Space is big. You just won't believe how vastly, hugely, mind-bogglingly big it is. I mean, you may think that it's a long way down the road to the chemists, but that's just peanuts compared to space. Douglas Adams Hitchhiker's Guide to the Galaxy.
Yay.
But how big do you think space really is? So let's go get a spaceman's perspective. So let's go, Brian. So first off, we're going to go to the moon. But how far is the moon? So, question, if the Earth was the size of a golf ball, I don't think I've got a good golf ball analog around here.
Make
but-
one of tape.
Just
it's actually probably about the size of the end of the mic, around
Oh, there
so
you go.
4 centimeters. Yeah, perfect. So if Earth was about this big, how far away do you think the moon is?
Out on the road.
A whole ass block.
So yeah, okay. So go like there.
In Toronto.
Maybe this room.
the moon. It's all over.
Not quite. So if you think about when you see the moon in the sky, you can kind of make it out. It ends up being about the size of your thumb when you hold it up. A lot of people will give an answer like Cole just did, that it's like kind of like somewhere in here, but it's actually about 1.2 meters away. So like something like this. And at that scale, the moon is about the size of a marble, about 1 centimeter marble. So again, about the size of your thumb. And that's a pretty long way. Like these two things are dancing around each other continuously, but when you see it, it's like, wow, that's so big. But it's part of the thing is that when you look at the sky, the moon's like the only thing you got to frame a reference on. One sec. Now that I have, can I do this? Will it work? No. Let's see if this works.
Oh yeah.
All right. So now that we've gone to the moon, we're going to keep going, and we're going to send Brian off to the sun.
Oh no!
Because we're going to need to go farther out, and to get farther out, we're going to do what's called a gravity assist. So we're going to.
Did you put a sun reflection?
Yes. So we're going to send Brian and swinging past the sun. He'll be fine. He might get a bit toasty, but he'll be okay.
I'm losing my mind.
Yes.
Is this a tool-assisted galaxy quest?
Yeah.
Well, kind of.
Okay. This is fine.
Glitches on or
I
off.
don't know.
So he's going to go zipping around, pick up a ton of velocity, and cruise out of the solar system. But to do that, we need to figure out how far away is Brian going to have to go to get to the sun. So if we go back to our golf ball Earth, it's right here. The moon is 1.2 meters away over here somewhere. They're spinning around. How far away from here is the sun?
Regina.
No. It's a lot. It's closer than that. Any more guesses?
2 meters.
Surrey.
One Vancouver city
No.
block.
Closer.
Okay.
Very close, actually.
Oh.
So, if the Earth is the size of a golf ball, then it would be 500 meters away, half a kilometer. That's about Metrotown Station from here. And it would be about 4.7 meters in size. That's about half the height of a telephone or of a street light. That's 3 Bryans tall.
Oh.
Three Brian.
Damn.
The sun has an actual diameter of 1.4 million kilometers. That's also the definition of an astronomical unit, is an AU, if you've heard that before. That's the distance between the Earth and the sun. That's how we measure light.
Is that Earth's furthest point from the sun?
It's about average.
It's average. Okay.
Perihelion and aphelion, which is the term for closest or farthest distance from something, for the Earth is pretty narrow. It's not a huge, we're not super elliptical, but anyway.
Helium is a magic card. How do you?
Oh my God.
Well, no, that's
Get
the
it.
second one.
Oh yeah, sorry.
The first
My
one is
mistake.
the regular
My
term they
mistake.
use. They were like, well, they can't use the term again, it has to be the sequel to the term.
My
Helium.
mistake, yes. I'm
So,
right.
all right, Brian has gone to the sun. He's zipped past the sun,
Bye.
shooting out into space farther away, and we're going to go cruising past some planets. We've got Mercury. Mercury is the size of a marble. It's a little bit smaller than the moon. It's 200 meters away from we're going from Metrotown Station, where the sun is. About one platform of the SkyTrain away, 200 meters. Oh, no, say twice the length. We have Mercury. Venus is also a golf ball size. It's in the Walmart parking lot from Metrotown Station. Earth, as we just discussed, is here from Metrotown.
Oh boy.
Mars is about the size of a quarter. A little bit bigger than the other ones at the size of a marble. A little bit bigger. It's about Patterson Station from Metrotown Station. Then we get to started getting to the outer planets. Jupiter. So Jupiter's 318 times more massive than Earth. It accounts for 0.1% of all the mass in the solar system, which, of course, the sun is 99.8% of the mass in the solar system, which means all the other planets, all the asteroid belt, everything else is 0.04%. And that includes Saturn, which is not that much smaller. Anyway, so it's about the size of a beach ball. It's 770 million kilometers from the sun. And that's a bit more of a jump from Mars, which was at Patterson Station. Jupiter's at Joyce Collingwood, 2.6 kilometers from Metrotown. Of course, we get to Saturn. Saturn is sometimes called the crown jewel of the solar system because of the rings. It's very pretty. It's significantly farther. It's 4.8 kilometers away over a commercial Broadway station. That's the size of the gap between Jupiter and Saturn. Jupiter is so powerful and massive with its gravity that it cleans out this gigantic orbit around it and cultivates I think it's 68 moons or something like that for Jupiter. Anyway, moving on, we're now going very far out. We're in what's sometimes called the outer dark. We get to the ice planets. Uranus is it's about the size of a baseball, and it's toppling all along head over heels instead of turning the same way all the other planets do. It's tumbling head over teacup. Yes.
How do you decide what is head and what is sideways in space?
So you do it by
Polar.
Well, I think the real way that we often do it is, north versus south is really hard to define.
Yeah.
But everything is turning on its axis.
Yeah.
So it's more like when we say.
It spins on
it's
its axis.
It's in line with the axis of the solar system.
Okay.
So the planets are all going around in the same direction.
Yeah.
And most of the planets are all spinning the same direction.
Yeah.
So we generally define that as being up and down because it's more useful for us as a frame of reference. So you're totally right, you wouldn't have to. And Uranus, unlike the other ones, instead of turning like this, is going like this.
Okay, gotcha.
And so it's even farther. It's over in Scott Road Station from Metrotown, way over past. Alternatively, if you'd like, it's in downtown Vancouver. It's about the same distance going that way, but I'm running out of distances to go. So I'm going to go towards Surrey. Neptune, which is kind of our last true planet in terms of the way we define them now, is about the same size as Uranus. I'll get to that. Shaking of the head.
Don't even.
It's 20 kilometers away, about the same position as Coquitlam Central Station from here.
Christ.
Or another 5 kilometers farther than Scott Road down into Surrey.
And you
But
can
I said
still
it's
see it. That's crazy.
And you can still
Yeah.
so Neptune's the only one you can't see with the naked eye.
That's the last one. It's,
So we now get to Pluto, Charon, Nix, and Hydra, which is a 4-body system. Part of the reason they're not defined as being a planet anymore is because they don't orbit inside Pluto. Pluto doesn't spin like this. The whole thing goes like this, in like a big four-body dance. And the other reason, of course, that we don't talk about Pluto in that regards anymore is there's about a dozen other similar-sized bodies that are farther out that we'd have to be like, all the kids, remember the 24 planets of the solar system? So that's part of the reason with the Pluto thing. So, and of course, they're a lonely distance. They're 6 billion kilometers from here. As we've talked about before, the difference between a million and a billion, that's a long way. Pluto's basically at the McDonald's in Swanson from
Kelson!
Kelson!
Not quite to Kelson's house.
He's in the
but
outer dark.
it's pretty far in the
I miss you,
All right.
Kelson.
But of course, we've gone a long way. There's many of these other dwarf planets to go.
That's fine. That's okay.
So, what could be next for that boy? We've got, of course, Haumea, Make, and Sedna here, which are some of these dwarf planets farther out.
Why is it a
Yeah.
That's what it looks like.
That's insane.
Yeah.
It's not big enough to actually become a sphere.
It's like a ghost.
But what could be next for that boy? Well, the nearest sun to us here is the Alpha Centauri system. That's 4.5 light years away from here. Or 4.2 light years away. But how far is that from what we were just talking about with Earth being a golf ball? Now, I'm going to shrink things to make things a little bit more reasonable in terms of guessing. So if we now say that the sun is the size of a marble, so we're shrinking our model down by 70 times. How far from here do you think that Proxima Centauri, the nearest star to us, is?
Regina.
I was gonna say Regina again.
Closer.
Victoria.
Farther.
Nanaimo.
Closer.
Whistler?
Merit.
Sam?
I'm not sure.
Like Bam?
I think farther though.
Banff is a good
Merit.
one.
Farther.
Okay.
No, it's farther. So the answer.
The U
Closer. So,
Lethbridge.
okay, so,
Red Deer
let
Alternative.
me,
The atmosphere.
I'm gonna play that song again. All right, so here we're sending our boy tumbling through space.
Oh, I'm tumbling.
So, as we said, approximate target is 4.2 light years away. Okay, so how far is a light year? Well, we remember that a marble's in the scale in this. A light year is 69 kilometers.
Nice.
So from this room, the next star would be sitting as another marble in Kelowna.
That's terrifying.
That's how big empty space is. So whenever you think about a story being like, and then they took off and they flew across the galaxy, it's scary as shit.
Yeah.
Because you're basically saying this mote of dust has nothing to land on, nothing to help it, and it has to fly to Kelowna. And in this case, we're talking the sun is the size of a marble. Earth is like a poppy seed. It's nuts. I think that I'm of the opinion that when it comes to sci-fi and all this stuff, space itself is the cosmic horror. I don't need a monster out there. The whole place is scary as shit. Anyway, if we didn't shrink this model and said this was still the size of Earth, then the next star would be halfway to the moon from here.
Christ.
Damn.
All right. So,
Well, there he goes.
there he goes.
Bye, Brian.
So, some extra thoughts. If we shrink this model a little bit even more so that a light year is the size of a marble. So again, that's a crazy thing. 79 million times smaller.
Yeah.
But we now talk a light year is 70 kilometers when the sun is a marble. A light year now is that scale. So at that scale, then our Milky Way, the whole galaxy, is about 1 kilometer in size. And that gives you a bit of an idea of what we're talking about when we talk about the size of the galaxy. So, you know, when the story's like, and then they colonize the galaxy, and you go, that does feel like a bit of jumping the shark now, isn't it? But anyway, the nearest other galaxy that's actually big, Andromeda, is something you can actually see in the sky. If you're on a clear night and in the right place in the world, you can see it. It looks like about this big in the sky. It's about, I think, 3 times the size of the moon, although it's fainter. That is about the same, a similar size to the Milky Way. It is 25 kilometers from here at that scale, with 1 centimeter being a light year. It's coming towards us. What's called our local supercluster, that's our home family of galaxies. That's about 1,100 kilometers in diameter. So from here to like Calgary, a little bit farther.
Jeez.
That's how big our supercluster of local family of galaxies is. And then the whole observable universe that we know is 138,000 kilometers at this scale. That is, again, a third of the way to the moon. That's how big the universe is from our perspective.
That we can see. That's
what
how far
we
the
can see.
light goes.
Exactly. Because the age of the universe is defined for us in a way by how long light takes to get to us from the farthest possible events we can observe.
Yeah.
In this case, 13.8 billion light years away, making their way. So, as I said, it's a third of the way to the moon.
Sorry, Brian.
Anyway, but what about Brian?
What about him?
What about me?
So, I'm kind of running low on time here, but I do have a plan. I know a guy. So,
Oh my god. Bye, Brian, forever.
I sure hope not.
So will Brian make it home? Find him next time. Because I've now run out of time.
Hey.
So, thank you, and next time
Yay.
we'll join Brian on time travel through time.
Yay.
Space.
Amazing.
That was